This question is that. Let p, q, and r be three positive real numbers. Consider a function that is defined as follows. Take p raised to the power x plus q raised to the power x plus r raised to the power x. Divide that entire sum by 3. Then raise the result to the power 1 divided by x. What is the limit of this function as x approaches 0? Alright, let's work through this carefully together. We're being asked to find the limit of a function that looks like an average of exponential expressions, and the entire thing is raised to the power 1 over x. So what we're trying to evaluate is this. As x gets very close to 0, what does this expression approach? Open parentheses, p to the power x plus q to the power x plus r to the power x, all divided by 3, close parentheses, raised to the power 1 over x. The first step is to transform into a natural exponential form. Now, here's the trick. When we see something raised to the 1 over x, and the base is approaching 1, it's a good idea to use logarithms. So we're going to rewrite the whole limit in terms of a natural exponential function. Let's call our whole expression L. Then the natural logarithm of L is equal to the limit, as x approaches 0, of the natural log of that average expression divided by x. That is, the natural logarithm of L equals the limit, as x goes to 0, of the natural log of p to the x plus q to the x plus r to the x, divided by 3, all divided by x. Now this form is what we call an indeterminate form, which means we can use L'Hopital's rule. Next, apply L'Hopital's rule. Let's take the derivative of the top and the bottom. The denominator is just x, so its derivative is 1. Now, let's look at the derivative of the numerator. We first take the derivative of the natural log of a function. That gives us 1 divided by the function itself, multiplied by the derivative of the function inside. So we get 1 divided by p to the x plus q to the x plus r to the x, divided by 3, and multiply that by the derivative of the top, which is p to the x times the natural log of p, plus q to the x times the natural log of q, plus r to the x times the natural log of r, and all of that divided by 3. When we simplify, the 3's cancel out, and we are left with the limit as x approaches 0 of the following. In the numerator, we have p to the x times the natural log of p, plus q to the x times the natural log of q, plus r to the x times the natural log of r. In the denominator, we have p to the x plus q to the x plus r to the x. Then, take the limit as x approaches 0. Now we let x get very close to 0. Each of the terms like p to the x, q to the x, and r to the x all approach 1, since any positive number raised to the 0 power is 1. So in the numerator, we now have natural log of p plus natural log of q plus natural log of r. In the denominator, we have 1 plus 1 plus 1, which is 3. So this whole thing becomes 1/3 times the sum of the natural logs of p, q, and r. In other words, the natural logarithm of L is equal to 1/3 times the natural log of the product p times q times r. Next step is to exponentiate to get the final result. Now we exponentiate both sides, because we originally took the natural log of L. So now L is equal to the exponential of 1/3 times the natural log of p times q times r. That simplifies to the cube root of the product p times q times r. So the final answer is, the limit of the original expression, as x approaches 0, is the cube root of the product of p, q, and r. Whenever you see a limit that has an expression raised to the power 1 over x, and the base tends to 1, you should immediately think about using natural logs and rewriting it as an exponential limit. Take the natural log first, apply L'Hopital's rule if needed, and once you simplify the log expression, don't forget to exponentiate at the end to get your final answer. This is a powerful and elegant trick for solving limits that involve exponential averages. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel and turn on the notification bell. Press the like button. Thank you so much.